This week, along with each and everyone's main role, every team member was in charge of main roles, starting with research about Seoul by Woo Jung-won, Kong Tae-won, Park Jae-rim, story arrangement of modification by Yoo Sung-ho, and provision of review and preview plus presentation by Moon Hoo-jin. Now, let's begin our third presentation. We will start with the quick review about last week and move on to this week's episode about the head of the island. Let's see what the problem with it was and how they solved it. Previously, on our presentation, we have mentioned about the fast track method because the project scale was enormous and the client, being a country, Prime Minister interfered a lot between Atkins and other joint venture companies. This could result in scope creep, which is the unexpected lengthening of construction period and budget because of additional requirements. Also, before the construction, the design wasn't settled and expected construction period was short. Therefore, Atkins had to choose fast track method. Fast track method carries out main design and the construction at the same time. This method is effective in shortening the construction period and applying new methods in construction. The head of the artificial island, which we will study today, was also under this fast track method. Last week, we started the construction of Burj Al Arab's artificial island. To construct, they started with temporary tubular piles, along with sheet piles to form a shape of the island. And lastly, they filled the sheet pile area with sand and the outer area with rocks to set the island shape. Now then, what was the problem with the island heads? It starts with clash between architect Tom Wright and the engineer Mike Nicholas. Tom Wright wanted the yacht-shaped building to stand as low as possible near the sea, to resemble a real yacht floating. Also, lowering the island could enable the guests to enjoy their moments near the sea. However, there was a problem. Dubai is located near major fault line, which means there are frequent occurrence of earthquake. For this, Dubai shore had higher waves than other shores. These high waves could be dangerous to the guests if the island was too low. Engineer Mike Nicholas therefore strongly asserted that the island's height should be higher than planet. A huge clash has risen between the architect and the engineer over should it be world's best vacation spot or safe vacation spot. Applying the fast track method, the decision was made. They chose architect Tom Wright. How did they solve the high wave problems? The constructor decided to install seawall along the artificial island. Seawalls are known to be the most effective and classic way to calm down the waves.
Then, what's so special about Burj Al Arab seawall? Strictly speaking, seawall describes the whole structure that keeps out the waves. The blocks used in these seawalls are called breakwater armor units, or shortly, armor units. Dulles X-block tetrapod are typical types of these armor units. These types of units use interlocking method to install, which means the protruded sides interlock to one another. These models are placed randomly. However, Burj Al Arab didn't choose these typical units. They chose shed unit. The difference between the ones we've shown before and this jet unit is that this unit doesn't work by interlocking but by supporting adjacent units with friction. Placing the shed units creates a series of hollow spaces. These spaces are effective in reducing the wave energy. The waves that collided with this block rotate inside the unit's hollow space and gradually decrease the force. It is a structure that can effectively and safely block waves. Energy reduction wasn't the only reason they chose jet units. The exterior of Burj Al Arab also had to be perfect. Randomly interlocked armor units couldn't fulfill this. Shed units, which are placed uniformly, was therefore chosen. The seawall composed of these shed units could maintain the island's height to only 7.5 meters above sea level and enable the building to resemble a floating yacht. Now, how are these shed units installed? Shed unit stability comes from the friction between adjacent blocks, the thickness of layers, and the weight of the units. The friction between uniform blocks such as shed is less variable than the interlocking of randomly placed blocks such as tetrapod. In other words, it's a more stable form. On top of the slopes created by the large rocks that act as cores, the constructor stacks small rocks to build a foundation called underlayer. A flat type of unit is to be installed, so they must focus on flatness of the floor. A toe structure is installed in the bottom with boulders which could support the shed unit and block them from slipping. Cranes are used to move the shed units, and the final placement by divers are required for the precise installation. The units are placed in a regular pattern forming a single layer. Total of 3,370 units were used to cover every side of the artificial island. The artificial island has curved section. Therefore, in these curved places, concrete spaces were used to fill the gaps between the units. The units work by friction between each other. Therefore, concrete spacers are required. This is how shed units were constructed around the whole artificial island. Additionally, 20 years after Burj Al Arab was planned, corrosion-resistant materials were developed and matin bar, which is one of them, was used to reinforce the units. The 1,500 shed units, where the ties are strong, were replaced with reinforced units. The placement of these units was done in 2015, and how they installed was not different from the past method. The cranes on the sea carried shed units, and the divers and construction workforce placed them one by one for precision. As shown in the picture, there aren't any connecting tools between each unit. They are maintained only by the friction and their own weight. Until now, we have looked on the armor units applied on Burj Al Arab's artificial island and the construction method of it. Next week, we'll learn about water pressure. It doesn't matter when you're building a simple island, but if you must build a building on it, the foundation inside it is important. If the weight of the sand at the bottom and the pressure of the seawater outside the artificial island are not balanced in the process of laying the foundation, the seawater could penetrate. How do constructors solve these problems? We'll learn about this in our next presentation. Thank you for listening.